Okay, last time we left on carboxylic acid derivatives. And so remember, whenever you talk about a carboxylic acid, it's always going to be a carbonyl and a hydroxyl group, right? And what makes it a carboxylic acid and what's special about that we need to actually memorize, that is a unique thing, rather than, just going, oh, it's carbonyl next to a OH. So it shouldn't be like something alcohol, which it normally would be, right? Is because carboxylic acids have very special behavior. It has a lone pair here next to this double bond, and so that creates resonance, okay? And that gives you unique electronegative properties, right? Or another way of saying that is it greatly increases the reactivity, okay? And so the carboxylic acid derivatives are things that look a little bit like a carboxylic acid, and they have similar properties to a carboxylic acid. Or another way of saying that is they're things that you can react and make from carboxylic acids. Okay? So you can make and make from carboxylic acids. The easiest way to think about these is there's actually quite a large variety of derivatives, and new ones get added every now and then. Basically, it just has to be able to react to and from fairly easily and have sort of similar properties. Okay? But the ones that we'll typically look at and use the most are going to be things like the acid chlorides. This is the acid chloride. See how it's like a carboxylic acid, but instead of an OH, you have a chloride. Okay? And right there, that's the esters. This one has a unique name because it's an incredibly important common group in nature. Okay? And that's where that you'll see that the most. Anybody recognize that group, by the way? No? Who here has been in, what biologies have you guys gotten up to yet? Botany? Okay. Okay, you took this pretty early. Oh, wow. Microbiology right now? So you'll start seeing this in microbiology. Esters are the linkages, ester linkages, are the type of linkage that you would find in like fatty acids. Okay? They're also the type of linkage, by the way, fatty acids are called fatty acids because when you break the ester linkage, you get a carboxylic acid. I know, right? Anyways, let's go on to the next one, which is actually even more common, and you guys definitely have seen if you've taken biology, and that's an amide. Okay? An amide is going to have a carbonyl next to a nitrogen. This nitrogen can have other R groups attached to it, other carbon chains attached to it. Okay? Anybody ever heard of an amino acid? Why is an amino acid called an amino acid? Anybody want to try to figure out what the two functional groups on amino acid are? Yeah. So acid would come from carboxylic acid. So on one side it has a carboxylic acid. What do you think amino stands for? Amine, I know, right? That's actually like, you know how we were talking about like ethyl is an attached ethane group, is a substituent. Amino is the substituent form of amine. Okay? And so you have an amine on one side, you have a carboxylic acid on the other. That would be the monomer that you would know as an amino acid, and that would be your wonderful amino acids that form polymers oftentimes. Those polymers we call sometimes polypeptides. You may know them as proteins or enzymes. You guys have heard of proteins and enzymes, hopefully? You know they're related, repeated amino acids linked together. Okay, what type of linkage do you think they have between them? It's not a hydrogen bond that holds the polypeptide together or the protein together. There are hydrogen bonds involved in making its shape. Okay? But you actually have a long polymer. You can see this really distinctly because if you look at your head, everybody has these things coming out of it called hairs, right? Those are polypeptides, single-stranded proteins. If you're curly, they're, like that. If you're not curly and pretty straight, then they're going to be mostly not reattaching to themselves. And so it's a polymer, like a plastic. Okay? Now, the linkage between those amino acids when they come together to make the polypeptide, that's an amide bond. Okay? Biologists like to call them peptide linkages because they don't like to remember their organic chemistry, apparently. So, there you go. But, yeah, it's an amide linkage. It's just an amide functional group. So those are the most common carboxylic acid derivatives. Again, there are other ones. Here's the amines. This is going to be an alkylated derivative of ammonia. Ammonia being the NH3, right? Notice there's no actual limits on how many alkylations there is. Okay? So you could have 1, you could have 2, you can have 3, hell, you can even have 4, though it becomes an ammonium salt at that point. Okay? But typically it goes between 1 and 3, and that would be an amine. Amides, these are going to be the carboxylic acid derivatives with the nitrogen attached to the carbonyl group. Again, you don't. This does not tell you how many carbons are on that nitrogen, right? So it doesn't just have to be NH2 attached. It could have a nitrogen with another alkyl group attached. Okay. Nitriles. These are going to contain cyano groups. Anybody ever heard of cyanide before? Okay, this is similar to cyanide. Cyanide being the form that is an anion. Okay, in salt. This is the one that's attached to a carbon, so it doesn't have a charge, overall charge. This is your amine. Right here we see like methylamine, for example, triethylamine, has 3 ethyls around it. Piperidine, nicotine, anybody recognize nicotine? Okay. This is actually incredibly common pharmaceutically active compounds. Okay. By the way, esters are actually very common in things that smell nice, in case you're curious. Yeah, the carbonyl and amine groups have a very distinct smells to you. They're 2 of the groups that your nose very readily recognizes. Anybody know what the ammonia or amine smell like? What does the ammonia smell like? Yeah, it smells bad. Yeah, that's like Windex, right? Or bird feces if you let that build up. It starts giving off ammonia. Does anybody know what the amine smell is like? I'll give you a hint. Oftentimes when things rot, they'll start releasing amines that are light enough that they float up into the air and into your nose. Yes. It's that fishy smell. Okay? Specifically, as it rots, you get more of that fishy smell and it becomes overpowering, right? We'll talk about that more and how you can stop the fishy smell. Amides. These are amides here. Again, they're going to be derivatives that result from the combination of ammonia or an amine. And this finally is the nitrile. This is the cyano group right here. If it didn't have a carbon attached right here, then this could be a negative charge, and we call that cyanide. No, it's just be "ide" at the end, means negative charged anion. Yeah. And so there we have nitrile. Cool, huh? Okay. Again, that would be a cyano group. As a substituent, the functional group is called nitrile. I know that's one of the few ones that the names are actually quite different, aren't they? It's a holdover from historic. Okay, I'm going to stop that video there. I'm going to then go on.